Welcome to this video in which we will cover the second exercise of the first assignment of our course Competition, Policy and Strategy. In this exercise we will be talking about monopolies. So exercise is named Monopoly 1 and the exercise text is actually quite brief, as you can see. A profit maximizing monopolist produces at constant marginal costs, so lower C equals 60. And the demand function is defined as Q as a function of P equals to 120 minus P divided by 3. Now in the first exercise we are asked, or in the first task we are asked, to find the inverse demand function, so P of Q, and calculate the price, quantity and profit as well as consumer surplus that result in market equilibrium, right? So start by finding the inverse demand function and then identify and characterize the market equilibrium. Let's do this one by one. So the inverse demand function, of course, is simply solving the demand function Q of P solved for P of Q, right? So what we're basically doing is just rearranging the demand function that was given on the slide by solving it for P. With that out of the way, we can now find the market equilibrium in this situation. And we do so by stating first the profit maximization problem of the monopolist. Because we need to find out the profit maximizing price or quantity, either way, that the monopolist will choose, right? That is what will define the market equilibrium in a situation like this. So in a situation of a monopoly. In this particular case, we have constant marginal costs. So the cost function capital C of Q reads 60 times Q, right? That's just derived from the exercise text. Knowing this, we can state the profit maximization problem. So we can state the profit function, profits pi of Q, as a function of the quantity, of course, by considering the inverse demand function, so P equals 360 minus 3Q, and subtracting the marginal costs, right? So what is written in these brackets is basically price minus marginal costs times quantity, right? So what we have is the profit margin times the number of items sold. Now that we have identified the profit function of the monopolist, we can quite simply calculate the profit maximum, right? In order to find the profit maximum, we have to state the first order condition of this profit function to actually be at its maximum. And the first order condition, of course, is the partial derivative of the profit function with respect of the quantity Q. And first order condition of this maximum, of course, is that this partial derivative has to be equal to 0, right at the back over here. All right, so we simply calculate the first order derivative, and by rearranging and solving this first order derivative, namely 360 minus 6Q minus 60 must equal 0, by rearranging this expression, we find out that the profit maximizing quantity equals 50. And again, just as an aside, because we made sure that the profit function actually is concave, we can allow ourselves to be as lazy as to not look into the second order condition, which of course should always be done, unless you very carefully choose the functions that you are minimizing or maximizing respectively, right? Yeah, that's just an aside. So we know that the profit maximizing quantity of the monopolists giving the demand function and given his costs function, that this profit maximizing quantity equals 50. We can now use this profit maximizing quantity in order to find out what the price will be that comes with this profit maximizing quantity. We can find out what the price is simply by plugging in this profit maximizing quantity into the demand function, right? So we simply substitute Q for QM, or the profit maximizing quantity, and so what we get is 360 minus 3 times 50, which of course equals to 210. So now we know that the profit maximizing price in the market is 210. Now, knowing profit maximizing quantity and profit maximizing price, we of course can calculate the profit, the actual profit of the monopolist in this situation. We do so by plugging in quantity and price into the profit function, which we already discussed and already stated, right? We simply have to plug in the numbers for the parameters, and we find out that the maximum achievable profit of the monopolist in this situation is 7,500. What we can also calculate, knowing the demand function as well as the market equilibrium, is consumer surplus. Because consumer surplus, just as a quick reminder, is simply the area below the downward sloping demand function and the equilibrium price, right? So we know the equilibrium price, we know the downward sloping demand function, so we can calculate consumer surplus as well, just as it is written down here. Again, we are relying on the more general expression where you calculate consumer surplus as the integral below the demand function and above the market equilibrium price. But knowing that in this case, again, the demand function is a linear function, you can simply calculate this triangle as a triangle without relying on the integral. Now, if we use the equilibrium quantity, equilibrium prices, etc., we can calculate this area and we can find out that the consumer surplus in equilibrium is 3,750. And of course, knowing profits as well as consumer surplus, we can then calculate total welfare as the sum of both, so 11,250. Now in task B, we are asked to find the price, the quantity and the welfare that result in the perfect competition. So we are not looking at a monopoly anymore, but instead we consider a situation where we have, per assumption, perfect competition on this market. We are asked to calculate the gain in welfare in comparison to the monopolistic situation that we were just looking at. So let's find the market equilibrium under perfect competition. Of course, what we need in order to do so is to remind ourselves that under perfect competition, the price in the market equals the marginal costs of the firms, right? So this equilibrium price under competition or perfect competition, denoted as P with an upper C on the following slides, simply is equal to marginal costs. And marginal costs, of course, were stated to be 60. Knowing the equilibrium price, we can then calculate the equilibrium quantity in the market, again similar to what we did just a few seconds ago, by plugging in the equilibrium prices into the demand function and thereby finding out that the equilibrium quantity in perfect competition would be 100. All right, now we know the equilibrium, right? We know the price, we know the quantity in equilibrium. So what we can do next is calculate the consumer surplus in this situation. We can, of course, again rely on the integral in order to calculate the consumer surplus, but again, we can simply calculate the triangle that is defined below the demand function, which is linear in our case, and the equilibrium price in the market. Knowing that this situation is perfect competition, we already know that profits in this situation, of course, are equal to zero. Simply because, well, price equals marginal costs, and in this situation, price equals average cost then as well, right? So profits of all firms are zero. So the total welfare simply is exactly the same as the consumer surplus in a world where profits are zero. So total welfare in this situation results as 15,000. In order to calculate the gain in welfare, well, we simply compare the welfare that we found on the perfect competition with the welfare that we calculated under the monopolist. So what is written on the slide is delta welfare is simply the difference between the welfare on the competition and the welfare in the monopoly. We simply calculate this difference and find out that the welfare increased by 3,750. So moving from a world where there is a monopolist towards a world where there is perfect competition, there's actually a gain in welfare in this order of magnitude. Now in task C, we are asked to consider or to analyze what happens if marginal costs increase. So we are now to assume that the marginal costs increase to some value C with a now lower n, so C new, which is larger than the original marginal costs C. We are asked to show that a monopolist passes on this cost increase underproportionally to his consumers. Now, how can we show what is asked to show? Well, the hint gives it away. We are asked to analyze how the equilibrium price changes with an increasing C. So, in order to answer this question, we start by stating the profit maximization problem of the monopolist, but now we stick with the parameters because we want to see what happens if we change C, right? So this is just, this is nothing but the general notation of the monopolist problem. So we have the quantity sold times the profit margin, P minus C. And if we then find in this general notation what the profit maximizing price is, we again look at the first order condition of the profit maximum and find out that this expression needs to be equal to 0. So A minus 2 times P plus C needs to equal 0. So if we now take a look, if we now want to analyze what happens with the price if marginal costs change, it is of course handy to find an expression where price is on the one hand side and marginal cost is on the other side, right? So we simply rearrange this first order condition so that we find the equilibrium price in the monopoly, which is simply P equals A plus C divided by 2. Now with this expression, we can consider a situation in which the marginal costs Cn are introduced, and Cn is simply the original marginal costs C plus some increment which we will call delta C. Assuming that delta C is positive, this is equivalent to saying that Cn is larger than C. So we have actually a costs increase. All right. So we can now plug in this new marginal costs, Cn, into our expression for the price the monopolist will set in order to maximize their prices. And if we do so, we find out that the new price of the monopolist, Pmn, equals A plus C plus delta C, all divided by 2. And this expression, of course, can be pulled apart into, let me just write it down on the slide. We have A plus C plus some delta C all divided by 2. Well, that is the same as A plus C divided by 2 plus delta C divided by 2, right? So this expression can simply be rearranged. And now this first part is exactly Pn, right? Just convince yourself that this is the same. So what we can see is if there is a price increase happening, so there is some Cn which is larger than C, excuse me, there's a mistake, of course. Delta C should be divided by 2. So if there is a price increase happening, so we are adding some delta C to the original marginal costs, then we see that the new profit maximizing price of the monopolist is the old profit maximizing price plus the increase in price divided by 2. So what we see is the new price, or the price, is increased under proportionally to the increase in price, right? To the increase in costs. The costs increase by delta C, price increase by delta C divided by 2. The reason for this underproportional pass-on of the increase in costs is that, well, if we already are at a high price, or if we are at higher prices, that the demand reacts more elastic. And more about elasticity in a minute, but just for now, let's just accept this, that demand reacts more elastic, which means that a larger reduction in quantity happens for any given increase in price, right? So the demand reduction effect is over proportional to the price increase effect.